So, what's the next big thing for AI? The real game changer. It's not just about making it faster or crunching more data. No, it's something way deeper. It's about building an AI that can finally understand the world like we do by asking that one simple, super powerful question: why? Let's dive in and figure out what that actually looks like.
Okay, to really get what I'm talking about, let's kick things off with a classic puzzle. The data shows a pretty much perfect link between ice cream sales and drowning incidents. As one goes up, so does the other. Now, a simple AI looking at that might just say, aha, ice cream causes drowning. But come on, we all know that's just ridiculous, right?
And this little puzzle gets right to the heart of the matter. Most of the AI we use today is an absolute wizard at spotting patterns like this. It's fantastic at finding correlations, but it completely misses the hidden reason, the why. In this case, of course, it's hot weather. Hot weather makes people buy more ice cream, and it makes more people go swimming. This inability to get from what to why is AI's biggest blind spot.
Now, this isn't just a fun little brain teaser. It's a genuine crisis for AI. Because when our systems can't tell the difference between a real cause and a random coincidence, well, that leads to some really serious problems. I mean, just think about it for a second. These AI systems can soak up all the biases hidden in their training data and then just make them even worse. They have zero common sense, and they are super brittle, you know? They just completely fall apart when they see something new. And maybe the biggest problem of all, they can't explain themselves. They can tell you what they think is going to happen, but they have no clue why.
So here's the bottom line. If we ever want to build AI systems that are genuinely smart, that are fair, and that we can actually trust, we have to teach them to think about cause and effect. The next great leap for AI isn't about correlation. It's all about causation.
Okay, so how in the world do you teach a machine to think like that? Well, luckily, researchers have given us an amazing framework to help us out. It's called the ladder of causation, and today, we're going to climb it step by step. This whole idea breaks down causal thinking into three really clear levels, or rungs on a ladder. The first one is seeing, which is all about association. The second is doing, or intervention. And the third, the most powerful one, is imagining, or what they call counterfactuals. Let's start right at the bottom.
All right, welcome to rung one. This is the world of just watching, of seeing patterns in the data without touching anything. It's actually where pretty much all of today's machine learning lives and breathes.
Association is really about answering the question, what is? So, for example, if we observe a symptom, how does that change the probability that a patient has a certain disease? It's all about updating what we believe based on what we see happening in the world, just as it is.
And this is the home turf for modern AI, for sure. When an algorithm spots your face in a picture, or guesses what movie you're going to love next, or flags an email as spam, it's working on this very first rung. It's incredibly powerful stuff, but it's got a huge limitation.
And that limitation has a fancy name, unobserved confounding. It's basically the technical term for our whole ice cream problem. We can see two things happening together, but at this level we have no way of knowing if A is causing B or if some hidden thing, C, the hot weather, is actually causing both of them. Here, we're stuck forever in the land of correlation.
So to get past that roadblock, we have to climb up to the second rung. This is where we stop just passively watching the world and start actively changing it. This is the level of doing. And right here, you can see this massive jump in thinking. On rung one, we might ask something like, of all the patients who decided to take this new drug, what was their recovery rate? But that data's a mess, right? Maybe only healthier people chose to take it in the first place. Rung two asks a way more powerful question. What would the recovery rate be if we made everyone take the drug?
This is the level of intervention. It's all about answering the question, what if we do this? This is the foundation of science. It's the whole idea behind clinical trials for new drugs, A/B testing on websites, and figuring out if a new policy will actually work. You're not just an observer anymore. You're an experimenter.
So how does an AI even do this? It starts by building what's called a causal model. You can think of it as a little map of how the AI thinks the world works. As you can see in the diagram, the AI agent uses this map to think about the parts of reality it can't see directly. This is what lets it predict what would happen if it actually went in and changed something, finally separating the idea of doing from just seeing.
Okay, so we've seen and we've done. And now we get to the very top of the ladder, imagining. This is the world of counterfactuals, of reasoning about alternate realities, and asking what if about things that have already happened. And the stakes up here are incredibly high. The researchers who created this whole framework say that this kind of thinking is absolutely essential for things like assigning credit or blame, figuring out who's responsible, and really truly explaining how things are connected. It's what lets us reflect and learn from the past.
And this is where we can start to tackle some of society's toughest questions. For instance, you can't answer a question about fairness, like this one, just by looking at data or even by running an experiment. To figure out if discrimination played a role, you have to imagine a world that never existed, a counterfactual world where only one thing, like gender, was different.
And what's amazing is that causal AI actually gives us the mathematical tools to do this. This diagram shows a really cool concept for that. Think of it like a prism. It lets an AI take a single outcome, like a difference in hiring rates, and break it down into its different pieces. It can separate the direct effect of a protected attribute from the indirect effects of other factors, and it can even spot those misleading correlations we talked about at the beginning. It's a way to mathematically pick apart why something really happened.
So, we've climbed the whole ladder. We've gone from just seeing patterns to acting on the world to imagining totally different worlds. What does all of this mean? What does a future with truly causal AI even look like?
It means we can finally start building the kind of AI we've always hoped for. Systems that are safer because they get the consequences of their actions. More robust because they don't just collapse when the world changes a little bit. Fairer because they can actually find and fix biases. And finally, truly explainable because for the first time, they can tell us not just what, but why.
And look, this isn't just some sci-fi dream. It's happening right now. Causal AI is already being put to work to build fairer loan applications, to help make smarter public health decisions, and even to speed up the discovery of new medicines by understanding the real causes of disease.
Which brings us to one last thought. For years, AI has been this kind of mysterious black box, a master of correlation but a total beginner at causation. But now, by climbing this ladder, we're on the verge of teaching it to finally ask why. So I'll just leave you with this question. Once AI can truly understand why, are there any limits to what it can help us understand?